All right, so we're going to investigate angular velocity here by looking at a record player. So we're looking at the top, looking down on the top of a record player, and we see we have a record sitting there, and we have two bugs sitting on the record. One is on the near the outer edge of the record, and one is sort of closer to the center or sitting on the label of the record. Now we're going to turn this record player on. And now you can see that they're both rotating at the same rate, right? Because, of course, the record is rotating, say, I don't know, 33 RPM or whatever a record, there's a couple different speeds, rotational velocities that a record might turn at. But regardless of what that velocity is, they're both rotating through the same number of degrees in the same time interval. So their angular velocities are the same. Now we might say, well, which bug is moving faster? And by that we might think about a linear velocity. Now, neither one is traveling in a line, but when we say a linear velocity, which one has a bigger circumference? One is moving about a much bigger circle. The outer one, of course, is moving about a much bigger circle. And so its circumference that it's traveling in a set amount of time is much bigger than the bug in the middle. It's traveling about a much smaller circumference in the same amount of time. So we say they have the same angular velocity, but the bug that has the bigger radius on the outer edge, it has a bigger linear velocity because its radius is larger. And so as a result, its path, or the length that it's traveling in a set amount of time, is longer. So the arc length is bigger than the arc length of the inner bug. And so its linear velocity is greater than the bug sitting in the inside on the label, even though neither one is really traveling linearly. They're not traveling in a line, but the linear velocity of the outer bug is larger.